Good day and welcome, grade 10s. This is Mr. Simons. In this lesson, we're going to be solving equations involving difference of two squares. So generally, every exam question, there must be at least one difference of two squares problem. So when we say difference of two squares, the word difference means minus or subtraction. Difference from primary school. If I say perfect squares, I assume you know 16 is 4 times 4. I know you know 64 is 8 times 8. X squared is x times x. If you look this side, 4 is 2 times 2. P squared is p times p, and 81 is 9 times 9. But the key is there must be a minus sign or subtraction sign between the two to make it a difference of two squares. So to factorize this process should have been shown to you in grade 9 already, but you will read to it. So 16 is 4 times 4. X squared is x times x. 64 is 8 times 8. And the only difference is to get a negative sign, it will always be positive times negative. So when I multiply two different signs, it's the only time I get a negative. So you can see the terms in the bracket are the same, but the one is negative and the other one is positive. From there we apply the zero factor law, which says 4x minus 8 equals 0. If I take negative 8 over, it will become positive 8. There 4x plus 8 would equal 0. If I take positive 8 over, it becomes negative 8. Right? Always divide by the coefficient of x. So 4x, I want x. That's why they say solve for x. I want x to the power 1, so I have to get rid of the 4. So that becomes 8 divided by 4. And that gives me x equal to 2. On the side, minus 8 divided by 4, which then gives me x negative 2, so I have solved for x. Look at the second one, 4p squared minus 81 equals 0. 4 is the same as saying 2 times 2, p squared p times p. 81, 9 times 9, but again one bracket negative, other one positive. It's up to you where you want to put the negative and positive, but the key is the brackets must have the same terms in it. So from there, if I take negative 9 over, I can say 2p equal 9. Or there, 2p, if I take positive 9 across the equal sign, becomes negative 9. So from there, p equal 9 over 2. Or p equal minus 9 over 2. Which you can rewrite as 2 goes in 9 4 times. Leave a remainder of 1, so it's 4.5. Or negative 4.5. So these are your two easier variations. I'm going to try to work through all of them except one. I'll do a whole extra lesson just on that more complex difference of two squares that appear in exam. So number 3, problem that's commonly asked in grade 9 and forever catch learners out. X to the power 4 minus 16. So x4 can be written as x squared times x squared. 16 as 4 times 4, not 8 times 8, but 4 times 4. So in the brackets, x squared times x squared gives me x4, 4 times 4, which gives me 16, positive times negative. X squared plus 4 stays, but there's still difference of two squares. So x squared can be written as x times x, and 4 can be written as 2 times 2. For the negative, negative times positive. Now that gives me x squared equal negative 4. And to get x, I'm going to find square root of negative 4, which has no solution, or we say no roots. And when we do nature of roots in grade 11, you will learn that this is non-real roots, or under classification we explain non-real roots. So the sum of two squares has no factors and can't be factorized. The side x minus 2, if I take negative 2 over, becomes positive 2. So x equal 2. And x plus 2, if I take positive 2 over, simply becomes negative 2. Right, now number 4 is a more complex exam variation. Let's look at it. So 1 over 36 x squared minus 1 over 25. So as soon as we give you fractions, you switch off. Right, so listen very carefully. If I have 1 and 1 on top of the fraction, I ignore the 1 because 1 is simply 1 times 1. I look at the bottom value, and if I know my perfect squares, you should know 36 is 6 times 6. You should know 25 is 5 times 5, and x squared is simply x times x. So there, I just consider the bottom value. So you see for 1 over 36, 1 over 6 times 1 over 6, because 6 times 6 would give me 36. X times x, x squared. For 1 over 25, 1 times 1 stays 1, but for the 25, 5 times 5. Right, it's a negative sign, so one bracket must be positive, and the other one negative. So from here, I can say that 1 over 6x minus 1 over 5 equals 0. If I take negative 1 over 5 across, it becomes positive 1 over 5. This side, 1 over 6x plus 1 over 5 equals 0. If I take positive across, it becomes negative 1 over 5. So hope you follow. Now remember, when I said we solve for x, we want x to the power 1. So whatever coefficient or values attached to x, to get rid of it, to get rid of 1 over 6, we're going to multiply by the reciprocal, meaning 6 over 1. Alright? That side as well, times 6 over 1. So 1 times 6 gives me 6. 1 times 5 gives me 5. Here, negative times positive stays negative. 1 times 6 comes 6, and 5 times 1 become 5. So if you're enjoying the lesson so far, like, share, subscribe. Alright, number 5 now. I'm looking at a more complex variation, and as I said, number 6, I'll do lessons on it separately. Alright. So for number 5, we try to hide the difference of two squares. If you look very carefully, I have x plus 3 and it's squared. So that's a perfect square, meaning x plus 3 times x plus 3. Minus 4, you should know 4 is 2 times 2, no? So perfect square. And x plus 16 squared is a perfect square, meaning x plus 16 times x plus 16. This perfect square and that perfect square is separated by a minus sign, therefore it's difference of 2 squares. So for x plus 3 squared, you see there, I left it in brackets, x plus 3 times x plus 3. That gives me the 2 brackets. No? Therefore, 2 times 2, and x plus 16 times x plus 16 gives me x plus 16 squared. So they are factorized via difference of 2 squares. Now, drop the bracket, that stays x plus 3. Negative 2 times x becomes negative 2x. Negative 2 times 16 gives me negative 32. There also, just drop, stays x plus 3. 2 times x would give me 2x. 2 times 16 would give me 32. Now if I say x minus 2x gives me negative x. Minus 32 plus 3 gives me negative 29 equal to 0. On this side, 2x plus x gives me 3x. 3 plus 32 gives me 35 equal to 0. Right? So if I take negative 29 across, it will become positive 29. But if I divide by the negative, then x equal negative 29. There, if I take plus 35 over, it becomes negative 35. We always divide by the value in front of x, my coefficient 3. So therefore, negative 35 divided by 3, and x equal negative 29, or x equal negative 35 over 3. So hope you follow, hope you enjoy the lesson. Wish you nothing but the best. Bye.